The problem name is number of islands. So we are given a min to n 2D binary grid which represents a map of ones for land and zeros for water, and return the number of islands. Return the number of islands. So island is the land. The complete land is island which is surrounded by water. So an island is surrounded by water and is formed by connecting adjacent horizontal. So island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. You may assume all four edges of the grid are all surrounded by water. Okay, in this fully outside the grid, all four edges are surrounded by water. You may assume like that. Suppose if the input is if the input grid is all ones, means that four sides will be surrounded by water, and we can say that this entire grid is an island. Return the, so here what we need to return the number of islands. Okay, and ones for land and zeros for water. Okay, so this is the given input. Okay, so this is the given grid. So I have returned in this. So I have written the given grid. This all full sides are surrounded by water. This, sorry, this all surrounded by water, and we need to return the number of islands that we can make. Here you can see return the number of islands. Here we got the number of islands as 1. Here we can see the number of islands that we got as 1. How we got that island? Let us see. So the land part is the island that we can make, right? So here this whole part is the island that we can make, because all are land surrounded by water. And this side is also water is there. In the question they told us to assume that the surrounded part is also all four edges are surrounded by water. So island is surrounded by water and is formed by connecting the adjacent lands. So we can connect adjacent lands horizontally or vertically. So here we can see that the lands are connecting horizontally and also vertically. So in this way we have made one island. And in the second example, so this is the second example. In the second example, we can, the output is given as we can form we can form 3 islands. How we can form 3 islands? This one is one island, and this one is another island, second island, and this one will be the third island, because the island can be formed only by combining the horizontal and vertical, not adjacent. So that's why this is forming a single island, and this is a single island, and this is becoming a single island. So here how can we solve this problem? So this problem is a type of a BFS approach. a type of DFS where we'll be searching the land. First, we will search the land and visit all its neighbors vertically and horizontally. So in this way, we will be visiting. First of all, I'll start from the 0 0 position till the end of the matrix. So first of all, I will start from here. I found that the land is here. Then I will visit and then I will make. So then I will traverse this grid. Then I will visit all the remaining neighbors. I will make them as visited. So I will go to right side and I will make it as visited. I will go to down. I will make it as visited. I will go to left side. I will make it as visited, and this is already visited. So I maintain a visited array, and I make them as visited, and I continue the loop, and I will check these are all not lands, and next from 0 0 I will move to 0 comma 1. Here we can see that this is also a land, but this is already visited, so then I can skip it instead of continuing DFS from here, because this is already visited, means one island we found. Instead of doing again, we just skip it so that we get the correct result. So next I go to here, here and here, and again I come to here. Here it is already visited, so then I will skip it. Here this land is also visited by the first land, so I will skip it and come to here, and this is not land, and I will directly come to next here, and I come to here. When I come to here, this is not visited, so I will make DFS on this from this index I comma j, and make visited we maintain visited array, right? So I'll make this I comma j and remaining neighbors as visited. So there is no remaining neighbors for this, right? So I will directly make this as visited, and there is no remaining neighbors. I continue the next. The DFS will be ended for marking the visited, and we make the count incremented. So we found 2 islands here. Now I continue my iteration here and here, and check these are not lands, these are water. And when I came to here, we found one land, and I mark the neighbors as visited, because the island may be big also. The island can be the combination of horizontal and vertical lands. So we can make a single island here. So these are all visited. So in this way, we are going to maintain a visited grid, and I'll be searching for the land and make the DFS and mark them as visited. So in that way, we are going to solve this problem. So I will directly write the loop. I will directly write the code. Here we got as 3 lands before, as explained. Here one island, here second island, here third island. So let us solve this. So let us take M as grid dot size and M as grid of 0 dot size. Here let us check the constraints. Here m and n are given from in the range of 1 to 300, means 0 can be supported. This doesn't make any error like array out of bounds. Such type of errors are not cannot be seen. This is C++. In Java we can see that if we access the element which is outside of the array, it will throw us the exception array out of bounds. Okay, now what I have said, I need to search the land and I will do the DFS from that searched from that land. So I need to have I need to also maintain the visited, right, so that I will not repeat the search again. Like I will not make the visited. This can help us to maintain the number of lands that we are visiting, number of islands that we are visiting. So this visitor will be of a boolean visited grid, and we need to count the number of count islands. Initially it will be 0. So for int I is equal to 0, I less than till n I plus plus. This is normal matrix traversal. J is equal to 0, j less than n, j plus plus. So in this way, we after while traversing, I need to check whether grid of I and j is equal to what here the data is of character type, so I have used single quotes. So we check whether this is a land and it is not visited grid, it is not visited, then only I will do the DFS. Then I mark them as visited. Instead of writing it as name as DFS, I mark visited, mark them as mark visited, like make island. I'll write the make island function. Make island function, or else I will write simply DFS instead of writing different names. So I j from ij and visited grid, and the grid we require. So we require these and n m. I need to pass n and m to make all the neighbors as visited. After completing this, we make count of islands incremented. Islands plus plus. We increment the islands count when we mark all the neighbors as visited, and return count of islands. Count of islands is returned. Here we need to call the DFS. Now here we need to write the DFS function that will mark all the neighbors as visited. So void DFS of int I, int j, and vector of, so this will be visited grid. I am passing it as reference, and we require grid. and grid is required, and we require int n, int m. So we require all this, and we are passing the parameters in this way. And if I is greater than n, and if j is greater than m, then we need to return just return, because this is a void function. Why? Because we are just marking the visited. So visited grid of I and j, mark them as visited, and I need to search in the neighbors, right? So how many neighbors I will be having? So for suppose I am on index ij, I can move up, I can move down, I can move right side, and I can move left side. So for moving up, down, right and left, we can see like this. So for moving upside, what we'll do? We'll do I minus 1 comma j. For moving right side, what we'll do? I will be staying on same index, and just the column will be incremented, j plus 1. And here the row will be incremented in order to come to the bottom, like down. The j will be same, only I will be changed in order to come down. And here I comma j minus 1, because this is the previous column on the same row. So in this way we are going to do. So I ensure okay, I will maintain these I variables in array. Like in the dx, I'll make the movements, like for this is for up minus 1, this is for right plus 1, uh, plus 1, this is plus 1, for moving down also plus 1, for moving left it is 0. This is for x, like I di, and dj will be we started from up to towards the clockwise direction, right? So j plus 0, j plus 1 plus 1, j plus 1, j plus 0, j minus 1, j minus 1, j minus 1. So we can achieve when we pass I j, we can directly use this indexes 0 1 2 3. We can directly use these indexes when I plus di of 0 means uh, j plus dj of 0. So what this will return? This will give us the upward direction value. Okay, di of 0, dj of 0 is I minus 1 comma j plus 0, means I minus 1 comma 0. This is like, so in that way we are going to use simply this two arrays for moving upward or downward, right side or left side. So this will be uh, const int di will be minus 1 minus 1 1 1 0 1 1 0. Const int dj is equal to 0 1 0 minus 1 0 1 0 minus 1. Okay. So for int I is equal to 0, I not I, so let us say direction as dir, direction is equal to 0, direction less than 4, direction plus plus, int x is equal to I plus di of 0, not 0, direction, int y is equal to j plus di of dj of dir, direction. Whether we will move, moving, we have 4 directions: up, right side, downward, and left side. So these directions can become overflow, like out of bounds, right? Uh, like here we can see when we pass a 0 0, suppose if we found the land at 0 0 and we pass a 0 0 to the DFS, then for this 0 0, how many, for suppose this is the matrix, and if we, for this one, how many directions will be there? One is upward, towards the right, and towards the bottom, towards the left. So if we move towards the left, what we will get? 0 comma minus 1. So this is making invalid, right? Like minus 1 is not, it cannot be used like for indexes. So this can make out of bounds cases. So for that we need to use one function to check whether the x and y are valid or not. So if is valid of x comma y are in this ranges, then what I need to do, I will visit those other, I will visit those x and y visited grid, comma, I will only visit if those are not visited, like if those are, if x and y are not visited, x y are not visited, then only I need to make the call to the DFS. And only I need to make the call to the DFS visited grid and the grid and n and m, and this is the grid, and n is passed, m is passed, and x y are passed. Okay, now we need to write just the is valid condition, int I comma int j comma int n comma int m. So return when I is greater than or is equal to 0 and j should be greater than or is equal to 0 and I should be less than n and j should be less than m, then only return true or else return false. Okay, now this DFS, what it will do, it will make the remaining x neighbors as visited. This is a neighbor x, neighbor y. Okay, now let us check the code. What is there any syntax errors? So now the n and m are taken from the grid. This will be for the row wise and this is for columns, and I make initially everything should be visited grid should be false, right? So I make these as false. false. Now the count of islands is equal to 0 initially, and I will be searching from in the row, and in the column it will be m. And when the grid of ij is a land, suppose here we found in the while traversing the grid, if we found the land and that is not visited, means we found one island, we mark the remaining neighbors as visited. So I pass the visited grid and normal grid and n and m to the dfs function. I increment this count of islands. That means we mark all the remaining islands as visited, remaining lands as visited. Next, in this dfs function, what I am taking I and j and visited grid as a reference, and grid as a character. We we check we check whether I is greater than n and j is greater than 1. Means this is out of bounds case, so we'll just return. Here we write is valid condition. Here we mark the I and j as visited. We mark the land as visited, and we see the four directions, that is up, right, down, left. We check this. We traverse these four directions, right? And the next direction is upward, right? So we check upward and downward and right side, left side are valid indexes. That means there should not be out of bounds case, and that is not visited x and y, and that should be a land, right? We missed one condition, and it must be a land. If we want to go to the neighbor and to mark them as visited, that must be a land, that must be of type land, and it is not visited. Then only we mark them as visited, and continue the dfs to mark the other remaining lands as visited. So let us run this. Okay, here okay, this is of type array. Array bound cannot be deduced from in class initializer. Okay, I will use vector instead of using this. So output is coming to a small change here. Here I have made a mistake. Like here we need to make them as 0. Previously I have written plus 1. Here it need to be 0. So here we need to make a change to 0. Minus 1 comma 0, 1 and 0, minus 1 0 1 0. Now let me run this. Now we got one island as correct. Now let me run the second example also. Now second one is also giving me the right answer. Now let me submit this. So now the code is working. Here we got accepted. So the time complexity here will be, here we traverse the entire grid n into m, and we do DFS, right? uh, n into m into DFS. What this DFS will do, it will be of time complexity will be 4 into it will visit all its neighbor, right? Suppose if all are lands, then it will visit n into m. It will visit all the remaining uh, 4 into the remaining directions. So the time complexity will be for n into m for searching the lands into doing DFS. For doing DFS, it will be 4 into 4 into, since this is a grid, we are suppose if all our lands in the grid 1 1 1 1 1, then this will make all of them as visited. So then n into m in 4 into 4 directions into what is let me see in Google what is the, so we can see that a DFS has time complexity of n square. This is for 8 directions, but here we are only traversing 4 directions, so it will be of time complexity of n into m, because we are visiting all the neighbors in the matrix form. If this is in the adjacency list, it will be of v plus c time complexity. So now the space complexity will be O of n into m for storing the visited, and DFS is going to take O of n time complexity for traversing all the rows, and if for traversing all the rows and also columns. Suppose if the matrix is like this, suppose we start from here, the DFS will go till here, and it can go also from here to here. It will be of time complex. The space, how much this space going to take, n plus m plus n plus m. It will be at most almost all is equal to n into m. This is for auxiliary stack space. Yes, this will be the time complexity 4 into n square into m square. Yes, that's it.